He has a Master of Business Administration degree from Harvard. So you will understand. That was what Brenda Miller from Human Resources said while sliding the printed compensation offer letter across the laminate conference table. My name is Gerald Vance. I am 50 years old. And I had just been handed a formal explanation for why a 26-year-old trainee was supposedly worth 60% more than me after I had spent 11 years keeping Zenith Specialty Chemicals operational. One single line on that paper told me everything about how this private equity firm operated. Senior Process Control Engineer, 11 years tenure, compensation aligned with internal equity guidelines. Internal equity meant that I was being paid substantially less than a fresh graduate whom I had just spent 6 months training on supervisory control and data acquisition systems. Accept it or leave, Brenda Miller repeated without looking at me. She checked off boxes on her clipboard to move to her next meeting. I did not raise my voice or slam my fists. I did not mention the plant shutdowns I had prevented or the Environmental Protection Agency violations I had helped avoid. Instead, I reached into my leather portfolio and pulled out a sheet of paper. My resignation letter was signed and dated. I slid it across the table with a calm smile and told her my resignation was effective at precisely 12:45 p.m. today. By 12:47 p.m., my security badge was deactivated. By 12:52 p.m., my SCADA network access was revoked. By 1:15 p.m., Chloe Brooks, executive assistant to Chief Executive Officer Wallace Thornton, was running across the asphalt parking lot in high heels, frantically screaming my name as alarms sounded. By 3:00 p.m., 9 top executives sat in an emergency crisis room, staring at an incident report ending with the words critical reactor lockdown with an estimated financial impact exceeding $3 million. But to understand how an underpaid engineer became the most expensive lesson in corporate history, you must understand how this plant functioned. My name is Gerald Vance. People on the floor called me Jerry. I am 50 years old, and I have spent 22 years keeping high-pressure industrial systems safe. I earned my engineering degree from a regional state university while working night shifts. Before entering civilian manufacturing, I spent 6 years in the United States Army Corps of Engineers, managing dam control infrastructure where a single miscalculation could flood entire towns. Military service taught me that when safety systems fail, excuses are meaningless. After the military, I worked through several industrial facilities before joining Zenith Specialty Chemicals 11 years ago. We manufactured high-purity chemical compounds for aerospace contractors. It was a volatile operation where precise temperature tolerances were non-negotiable because a runaway reaction could destroy a reactor vessel or cause severe casualties. When I arrived, Zenith was family-owned and managed by veteran chemical engineers. The facility operated on a legacy 1970s control system that stayed running because experienced engineers understood every mechanical quirk and sensor drift. I made myself indispensable by volunteering for midnight maintenance calls and hazardous line clearings. People across the plant adopted a rule: call Jerry, he will figure it out. In May of 2014, the primary reactor temperature control system spiked during a critical batch run worth $800,000. While plant management panicked, I traced the control loop and discovered a failing secondary thermocouple sensor. I implemented a manual bypass and recalibrated the signal loop, keeping the batch within specification. The plant manager sent a facility memo declaring that Gerald Vance had saved our quarterly numbers. That was the job: keep reactions stable, keep workers safe, and ensure the company remained profitable. Over the next decade, my role expanded. I rose to senior control specialist, designing alarm management protocols and human-machine interfaces for night operators. However, Human Resources always kept my official title below executive pay bands that required market adjustments. I did not mind as long as I had total authority over safety systems. I documented every failure mode from real emergencies, when lightning storms disabled programmable logic controllers or when contractors severed fiber optic control cables. I kept detailed technical journals because proper documentation is the boundary between safety and disaster. Then came the corporate takeover by Zenith Industrial Group, a private equity firm focused on aggressive cost-cutting. They appointed Wallace Thornton as Chief Executive Officer. Wallace built his reputation by slashing overhead and claiming short-term profit boosts. He spoke constantly about modernizing operations and eliminating tribal knowledge in favor of standardized software metrics. He brought in young business graduates who possessed polished presentation slides about efficiency, but had never worked a 16-hour shift troubleshooting a vibrating high-pressure pump. Wallace established the Executive Leadership Acceleration Program to fast-track young business graduates into management. Among them was Preston Davenport, a 26-year-old Harvard business graduate. Preston was academically sharp, but lacked practical understanding of industrial mechanics. Within 9 months, he was promoted to Director of Manufacturing Excellence, giving him authority over chemical control systems he did not comprehend. Loved holding seminars on digitizing manual workflows. He had never been on the factory floor during a midnight pressure spike, yet held arrogant opinions about our legacy safety. The breaking point arrived when Preston accidentally shared an internal compensation matrix. Although he attempted to anonymize salary figures, there was only one senior control specialist with 11 years of tenure. I saw my pay printed in black and white. I earned barely more than entry-level graduates, while Preston received a base salary 60% higher than mine simply for creating presentation decks about automation systems that I had personally built and maintained. That compensation disclosure changed my perspective. From that day on, I kept comprehensive records of every process safety warning rejected by Preston, every maintenance delay forced by cost-cutting, and every near-miss incident caused by ignoring experienced operators. The final straw came during my annual performance review in that windowless human resources conference room. My wife, Clara, and I were reviewing university tuition costs for our 18-year-old daughter, Audrey, who had been accepted into the chemical engineering program at Purdue University, costing $60,000 per year. We had 12 years remaining on our mortgage, and Clara relied on my medical insurance coverage for her chronic diabetes. When Brenda Miller slid that 2.5% pay offer across the table, while national inflation ran over 6%, I knew my career at Zenith had come to a close. She explains that leadership program participants like Preston Davenport held credentials commanding higher market value, while my role fell under legacy institutional tenure. When I asked if my options were to accept the terms or resign, she gave her cold ultimatum. I placed my resignation letter on her desk, effective at 12:45 p.m., signed with the pen I had used for 11 years. Brenda panicked slightly, asking if I would stay through the month to conduct knowledge transfer for Preston's team. I smiled quietly and told her all official maintenance procedures were filed within the corporate database. What I did not explain was that documentation is useless without operational intuition. Anyone can read a manual stating that Reactor 3 pressure relief valve sticks at 847 pounds per square inch. But reading that manual and knowing how to execute a manual cooling bypass at 2 o'clock in the morning when warning sirens ring out are two different matters. At 12:45 p.m., my security badge was deactivated at the main turnstile. I packed my tool set, coffee flask, and leather technical journals containing 11 years of irreplaceable notes. At 12:47 p.m., my laptop access disconnected. At 12:52 p.m., my phone network connection was wiped. I walked out to my truck in the employee parking lot and turned the ignition. At 12:58 p.m., my personal phone buzzed violently with an automated alert. Level 2 process, deviation, Reactor 3 high-pressure alarm, all qualified control engineers report immediately. I sat in my truck with the engine idling. Reactor 3 was the primary vessel equipped with a temperamental pressure transmitter that registered 15 pounds per square inch higher than actual pressure whenever outdoor temperatures exceeded 78 degrees Fahrenheit. Today, outdoor heat reached 82 degrees. My personal phone buzzed again with a text from Lyle Jenkins, senior control room operator. Lyle wrote, "Jerry, are you in the parking lot? Reactor 3 pressure is spiking and Preston is sitting at your workstation trying to execute a remote software reset to bypass safety interlocks. Can you come back for 5 minutes?" I typed back, "I no longer work for Zenith. Follow emergency protocol EP003 immediately. Seconds later, Lyle replied, EP003 is missing from the corporate database. Emergency protocol EP003 was the safety procedure I had written after a near-miss event in 2019. It detailed the exact manual valve sequence required to stabilize reactor 3 without dumping toxic chemical inventory. I had submitted it to the corporate portal, but Preston Davenport had placed it on hold, calling manual valve protocols old-fashioned. I shifted my truck into reverse. In my side mirrors, I saw operators in hard hats running toward the control building as yellow warning strobes flashed along the roofline. At 1:00 p.m., as I reached the main gate, my phone rang. It was Stanford Ross, Chief Financial Officer. "Gerald," Stanford shouted over the line. "We have a critical operational situation on Reactor 3, and the team needs your immediate intervention." I pulled off to the road shoulder and responded, "Stanford, I submitted my resignation effective at 12:45 p.m. My employment with Zenith is concluded." "I understand that, Gerald," Stanford yelled back. "But this is an active emergency. We face a catastrophic batch failure that could destroy $800,000 worth of chemical product." "What is the vessel status?" I asked. Stanford gasped. "Preston claims the automated relief system is malfunctioning. He is trying to force a manual software override of primary safety interlocks right now." "Listen to me carefully, Stanford," I said in an authoritative tone. "Tell Preston Davenport to step away from that console immediately. Do not let him override those safety interlocks. Reactor 3 has a known temperature calibration offset. If he overrides safety interlocks under thermal stress, he risks triggering a runaway reaction. Can you walk him through the recalibration steps over the phone?" Stanford begged. "The recalibration protocol is detailed in Emergency Protocol EP003, I replied. "He cannot find that document," Stanford cried out. "Then he must dispatch maintenance lead Toby Kowalski to inspect the analog pressure gauge directly on the reactor shell," I instructed. "If the analog reading differs from the control room screen by 15 pounds per square inch, he must adjust the baseline offset in the supervisory control system and initiate secondary cooling. Can you drive back to the control room and handle it yourself?" Stanford pleaded. "We will pay your extra hours today." "Stanford," I said quietly, "I am no longer your single point of failure. You have corporate managers and digital directors making 60% more than me. Figure it out." I disconnected and drove onto the highway. At 1:12 p.m., the emergency system issued a Level 3 alert, facility-wide production freeze. Reactor 3 automated lockdown initiated. All non-essential personnel evacuate Section 4 immediately. At 1:15 p.m., text messages flooded my phone. Toby Kowalski wrote, "Jerry, they completely panicked. Preston tried to force the digital override anyway, but the system auto-tripped into hard shutdown. The entire chemical batch crystallized inside the vessel lines. The plant is dead." At that moment, my phone rang again. It was Chloe Brooks, executive assistant to CEO Wallace Thornton. "Gerald," Chloe screamed over sirens, "Wallace demands that you return instantly. We have a full production shutdown, and you are the only person who understands the control logic for Reactor 3. "My employment ended at 12:45 p.m., Chloe," I replied smoothly. "This is no longer an employment issue," she yelled back. "This is an Environmental Protection Agency compliance crisis. If toxic venting occurs, we could face federal criminal liability." That statement made me pause. I cared about the safety of my former coworkers. "What exactly did Preston do?" I asked. Chloe sobbed. "Preston attempted to bypass safety interlocks when the pressure alarm triggered. The system executed an emergency safety dump into the relief tank. Now the entire reactor loop is frozen solid. Reactor 3 was engineered to fail safe," I explained. "If it went into hard lockdown, it did so to prevent a catastrophic explosion. You cannot force a restart without bringing in a certified chemical safety consultant." "How long will that take?" Chloe asked in horror. "Days," I answered. "Possibly weeks if federal regulators determine that safety interlocks were improperly bypassed without authorization." "Gerald, please," Chloe begged. "Can you come back as an emergency consultant?" "Name your price." I thought about Audrey's college tuition at Purdue, Clara's medical bills, and my mortgage. "You can retain my services through my independent technical consulting firm, Vance Automation Solutions," I stated clearly. My emergency rate is $350 per hour, with a mandatory 40-hour minimum retainer required up front before I step foot on your property. $350 an hour? Chloe gasped. That is $14,000 for the minimum retainer. That is what real engineering expertise costs when you no longer have it in-house, I said, and hung up the phone. I arrived home at 2:15 p.m., nearly 3 hours earlier than usual. Clara was sitting at the kitchen island, sorting through medical billing statements and university financial aid paperwork for Audrey. She looked up in surprise when I walked in carrying my toolkit and portfolio. "How did the compensation review go?" she asked gently. I pulled out a chair and looked at her directly. "I resigned today," I said. "Effective 12:45 p.m. Clara slowly closed her laptop. "What happened, Jerry?" I explained the meeting with Brenda Miller. The 2.5% raise during 6% inflation, Preston Davenport making 60% more than me while relying on my guidance, and Brenda's cold ultimatum. "So I handed her my resignation letter," I said softly. "And what happened after you left?" she asked. 13 minutes after my badge was deactivated, Reactor 3 suffered a process deviation. Preston tried to force a software override on safety interlocks, panicked, and triggered a complete automatic lockdown. The $800,000 batch is ruined, and the plant is completely shut down. Clara, who had worked as an emergency department nurse, understood high-stress operational environments. "Did they ask you to go back?" she asked. "The CFO and CEO assistant begged me to return," I said. "I told them my emergency consulting rate is $350 per hour, with a 40-hour minimum retainer paid through Vance Automation Solutions." Clara stared at me, and a proud smile spread across her face. "Good for you, Jerry," she said, clasping my hand. "It is about time they learned what your expertise is actually worth." Before I could reply, my phone rang again. The caller ID displayed the personal cell phone of Wallace Thornton, Chief Executive Officer of Zenith Industrial Group. I tapped the speakerphone icon and set the device on the table. "Gerald." Wallace spoke in a strained voice. "We have a severe operational crisis at the plant. Reactor 3 is locked down, our primary chemical line is offline, and we face massive penalties from our aerospace contract. I need you back in the control room immediately. My employment with Zenith concluded at 12:45 p.m. "Today, Wallace," I responded. "I am aware of your resignation, Gerald," Wallace snapped, "but this situation transcends employee relations. We face over $200,000 per day in lost production, plus nearly $1 million in ruined chemical inventory. I am prepared to offer you an immediate 5% pay increase if you return right now and restore control systems." I laughed softly. "Wallace, 5 hours ago Human Resources informed me that my 11 years of engineering experience commanded no market premium compared to a 26-year-old business graduate. Now you offer me a 5% bump to resolve a multi-million-dollar emergency caused by that same graduate. My answer is no. Gerald, be reasonable." Wallace yelled into the speakerphone, "Name your price to fix this vessel." "I am being professional, Wallace," I replied. "If Zenith Industrial Group requires my technical expertise, you can retain Vance Automation Solutions under a formal consulting agreement at $350 per hour with a 40-hour minimum retainer. Furthermore, I will not touch a single control console until your corporate legal counsel and insurance underwriters sign off on a process safety assessment. That is $14,000 just to get through the front door," Wallace shouted. "That is what operational competence costs when you drive it out of your facility," I answered cold. Before Wallace could argue further, another call beeped on my screen. The caller ID displayed Eleanor Ramsey, a member of Zenith Industrial Group Board of Directors whom I had met during a national safety compliance audit. I placed Wallace on hold and answered Gerald Vance speaking. "Mr. Vance," Eleanor said in an authoritative tone, "this is Eleanor Ramsey from the Board of Directors. I have been briefed on the catastrophic operational shutdown at the facility, as well as your resignation. I want to hear directly from you regarding what occurred." I provided Eleanor with an exact timeline, the meeting with Brenda Miller, salary equity disclosures showing Preston Davenport's inflated compensation, the refusal to adjust my pay for inflation, my formal resignation at 12:45 p.m., and the emergency lockdown of Reactor 3 at 1:15 p.m. Eleanor listened silently before asking, "Mr. Vance, what caused Reactor 3 to shut down so violently?" "Reactor 3 has a known thermal calibration quirk in its primary pressure sensor," I explained. "I authored Emergency Protocol EP003 back in 2019 to handle that exact edge case using a manual valve stabilization sequence. However, Preston Davenport removed EP003 from active approval because he wanted to replace physical safety protocols with digital automation software. When the pressure alarm triggered today, Preston attempted to manually override safety interlocks. The automated emergency system executed a hard safety lockdown to prevent a vessel explosion, dumping the batch and freezing the line. Why was EP003 not accessible to the engineering team?" Eleanor asked sharply. "Because management prioritized modern digital metrics over established safety procedures," I replied. "Preston considered my documented procedures obsolete tribal knowledge. But there is a far more serious legal matter that the board of directors must address immediately." "What legal matter?" Eleanor inquired. I opened my portfolio and referenced my technical legal logs. Under Title 17 of the United States Code, Section 106, I hold exclusive copyright ownership over the proprietary SCADA control scripts, custom automation algorithms, and specialized HMI diagnostic interface code implemented across Zenith facilities. I developed those custom software scripts on my personal time prior to my employment and licensed them to Zenith under an implied technical access agreement. When Brenda Miller revoked my system access and repudiated my employment contract today, that implied license was legally terminated. Any attempt by Preston Davenport or outside contractors to copy, modify, or execute my copyrighted control code constitutes willful copyright infringement under federal law. Furthermore, I continued, the specialized emergency pressure bypass valve configuration currently installed on Reactor 3 is covered under United States Patent Law, Title 35 of the United States Code, Section 271, registered under my name as sole inventor. If Zenith attempts to force an unauthorized manual bypass without my certified authorization, the company will be in direct violation of federal patent statutes, exposing the board to severe corporate liability, breach of fiduciary duty, and dissipation of corporate assets. There was a long silence on the line. "Mr. Vance," Eleanor said carefully, "you were telling me that our executive team allowed a critical safety protocol to be suppressed while placing our facility in direct violation of federal intellectual property laws and process safety regulations." "Precisely," I answered. "Your management team traded 22 years of verified operational safety for unproven spreadsheet theories. Now the board faces millions of dollars in equipment damage, regulatory scrutiny from the Environmental Protection Agency, and severe federal legal liability." Eleanor took a deep breath. "Mr. Vance, I am calling an emergency session of the board of directors within the hour. I would like to retain Vance Automation Solutions immediately to conduct an independent forensic audit of the facility safety infrastructure. We will agree to your retainer terms without objection." By 5:00 p.m. that afternoon, the financial toll of the shutdown was escalating rapidly. Zenith Industrial Group lost $200,000 per day in unfulfilled contract orders, and the ruined specialty chemical batch inside Reactor 3 represented an immediate write-off of $800,000. Combined with potential contract default penalties from aerospace clients, the total financial impact of my 12:45 p.m. departure approached $4 million. At 6:30 p.m., Eleanor Ramsey wired the $14,000 emergency retainer directly to Vance Automation Solutions' corporate account and sent a formal board authorization letter requesting my presence at the plant the following morning. When I pulled up to the security gate at 8:00 Friday morning, the atmosphere across the facility was drastically different from 24 hours earlier. Yellow hazard tape surrounded Section 4. Maintenance crews stood around anxiously, and the front executive office was in total disarray. I walked into the main administrative conference room, wearing my hard hat, safety boots, and work vest. Sitting around the large glass table were Board Director Eleanor Ramsey, Chief Executive Officer Wallace Thornton, Chief Financial Officer Stanford Ross, Human Resources Director Brenda Miller, and Preston Davenport. Preston looked completely drained, his face pale and eyes bloodshot after spending the night attempting to diagnose the frozen control loops without success. Eleanor Ramsey took control of the meeting immediately. "Mr. Vance," she said, welcoming me with a firm handshake. "Thank you for arriving promptly. The Board of Directors has granted you full authority to inspect control systems and present an unvarnished audit of this facility." I opened my portfolio, pulled out my inspection tablet, and addressed the executive room. "Let us begin with the root cause of yesterday's catastrophic event," I stated, looking directly at Preston Davenport. "When ambient temperatures reached 82 degrees Fahrenheit, Reactor 3 pressure transmitter registered a predictable 15-pound per square inch thermal offset. Instead of verifying the analog pressure gauge on the reactor shell as mandated by standard engineering practice, Preston attempted to execute a manual software override on safety interlocks to keep the production line running and avoid reporting a downtime metric. Preston cleared his throat nervously. "Mr. Vance, I was following digital optimization guidelines to maintain target output throughput. The alarm appeared to be a false positive software glitch." "It was not a software glitch, Preston," I interrupted firmly. "Safety interlocks exist under Federal Process Safety Management Regulations, specifically Title 29 of the Code of Federal Regulations, Section 1910.119, to prevent catastrophic pressure vessel explosions. Overriding an automated safety interlock on a pressurized chemical vessel without physical verification is not optimization. It is gross negligence. When you force that digital override, the system executed an emergency safety dump into the relief vessel, causing $800,000 of chemical compound to solidify inside heat exchanger lines." Brenda Miller spoke up, her voice trembling slightly. "Jerry, we were simply following internal corporate equity guidelines regarding compensation structures." "Brenda," I interjected, turning to face her, "your internal equity guidelines misclassified 11 years of specialized control system engineering as low-value institutional tenure while awarding a 60% salary premium to an uncertified trainee who did not understand basic plant mechanics. That misclassification directly caused the departure of the only certified control engineer capable of managing this plant infrastructure. Under corporate law, misrepresenting technical risk to justify arbitrary salary cuts constitutes a breach of fiduciary duty by management." Eleanor Ramsey nodded sternly. "Mr. Vance is entirely correct," she declared. "Over the past 24 hours, our independent legal counsel reviewed Mr. Vance's technical logs and confirmed that the custom supervisory control software algorithms operating this facility are indeed his copyrighted intellectual property under Title 17, Section 106. Furthermore, his emergency valve patents fall under Title 35, Section 271. Management's actions repudiated his implied license and exposed this board to massive federal infringement liability." Wallace Thornton shifted uncomfortably in his chair. "Eleanor, we can handle these intellectual property matters internally through corporate settlement." "Silence, Wallace," Eleanor ordered sharply. "The board has held an emergency vote. Effective immediately, Wallace Thornton is placed on indefinite administrative leave pending a complete board investigation into fiduciary mismanagement. Brenda Miller is terminated from her position as Human Resources Director for improper equity classification and regulatory noncompliance. Preston Davenport is removed from his role as Director of Manufacturing Excellence for gross operational negligence and dangerous safety interlock violations." Preston stared at the table in absolute shock, his prestigious Harvard degree proving completely useless against the harsh reality of industrial accountability. Brenda Miller quietly packed her folder and exited the conference room in tears. Eleanor then turned back to me. "Mr. Vance, the Board of Directors recognizes that this facility cannot operate safely or legally without your technical leadership. We are prepared to execute a formal licensing agreement for your copyrighted SCADA software algorithms and retain Vance Automation Solutions for a comprehensive 3-month safety infrastructure overhaul. We will pay your firm $75,000 per month for consulting oversight, plus a fair annual software licensing fee of $50,000. I evaluated the proposal carefully. That arrangement would provide Vance Automation Solutions with over $275,000 in revenue over the next 3 months alone. More than enough to pay for my daughter Audrey's entire 4-year chemical engineering tuition at Purdue University, clear our remaining home mortgage, and establish long-term financial security for Clara and me. I accept the consulting retainer and software licensing terms, Eleanor, I replied. But under one absolute condition. Name your condition, Eleanor said immediately. Every safety-critical procedure across Zenith facilities must be codified into a legally binding operational rule, I asserted. No manager, executive, or university graduate will ever have the authority to override an emergency safety interlock without written sign-off from a certified senior control technician who has at least 5 years of floor experience. We will call it the Vance Protocol. Over the next 3 months, I worked diligently through Vance Automation Solutions to rebuild the entire process safety architecture at Zenith Specialty Chemicals. I systematically audited all chemical processing units, cataloged 23 critical safety procedures that had previously existed only as unwritten institutional knowledge, and recertified every automated pressure interlock across the complex. Working alongside Senior Control Operator Lyle Jenkins and Maintenance Lead Toby Kowalski, we successfully flushed the solidified chemical inventory from Reactor 3, replaced damaged control valves, and restored full production without a single safety incident. The federal inspectors from the Environmental Protection Agency and the Occupational Safety and Health Administration conducted a thorough 2-week audit of the facility following our overhaul. Thanks to the rigorous implementation of the Vance Protocol, the plant received a clean bill of health with 0 safety violations, saving Zenith millions of dollars in potential federal fines and regulatory sanctions. Meanwhile, word of my successful independent consulting work spread rapidly throughout the industrial manufacturing sector. Executives from competing chemical firms recognized that reliance on unproven corporate management theories had created widespread vulnerabilities across the industry. Within 4 months of leaving Zenith, Vanguard Biochemical, a premier regional chemical manufacturer, offered me the permanent executive position of Senior Technical Fellow for Process Safety. The position came with a base salary 40% higher than my former pay at Zenith, full technical authority over all plant control architecture, and complete flexibility to continue running Vance Automation Solutions for independent consulting clients on weekends. I accepted Vanguard's offer enthusiastically, signing my new contract in a bright modern corner office overlooking Vanguard's flagship processing facility. With our financial future fully secured, Clara and I celebrated by paying off our remaining home mortgage 12 years early and establishing a dedicated educational trust fund for Audrey. Clara's health improved noticeably with the elimination of financial stress, and we were able to afford the highest level of continuous medical care and insulin management available. 6 months after the catastrophic incident at Zenith, I received an unexpected visitor at my Vanguard office. Lyle Jenkins had called ahead to tell me he was dropping by with someone who wanted to speak with me. When the door opened, Lyle walked in, accompanied by Preston Davenport. Preston looked remarkably different from the arrogant young executive who had once bragged about his Harvard credentials in conference rooms. He wore standard steel-toed work boots, navy canvas work pants, and a faded hard hat tucked under his arm. "Mr. Vance," Preston said quietly, extending his hand with genuine humility. "Thank you for agreeing to see me." I shook his hand and gestured for them to take a seat. "How have you been, Preston?" I asked. Preston took a deep breath. After the board terminated my management contract at Zenith, I spent 3 months applying for executive roles at other firms. But every time employers asked why I left Zenith after 9 months, the truth came out about the Reactor 3 lockdown. I realized that my business degree had taught me how to analyze balance sheets, but it had given me zero respect for the physical reality of chemical engineering and industrial safety. I was arrogant, Mr. Vance, and I caused a multi-million-dollar disaster because I refused to value your experience. I listened quietly as Preston continued. 2 months ago, I asked Lyle if Zenith had any entry-level technical openings. Lyle hired me as a junior process technician. I have spent the last 8 weeks working 12-hour night shifts on the factory floor under Toby Kowalski, learning how to manually calibrate pressure transmitters, rebuild control pumps, and trace physical piping systems from the ground up. I am earning a fraction of my former salary, but for the first time in my life, I am actually learning how a chemical plant works. I looked at Preston and saw a young man who had finally learned the most valuable lesson of his career. It takes a big person to admit past mistakes and start over from the factory floor. Preston, I said approvingly. If you respect the equipment, respect the safety protocols, and listen to veteran operators, you will become a far better engineer and manager than any business school could ever produce. Preston smiled gratefully. Thank you, Mr. Vance. Lyle is teaching me the Vance protocol step by step. I promise you I will never bypass a safety interlock again. 2 years later, I sat in the grand auditorium at Purdue University, watching my daughter Audrey walk across the stage to receive her Bachelor of Science degree in chemical engineering with highest honors. Clara sat beside me, wiping tears of joy from her eyes as Audrey accepted her diploma. During her valedictorian address to the graduating engineering class, Audrey spoke passionately about the future of industrial technology. Modern engineering is not merely about writing algorithms or building financial models on spreadsheets, Audrey declared to the audience. True engineering is grounded in unwavering ethics, physical safety, and deep respect for institutional knowledge. My father taught me that when corporate leaders sacrifice safety and expertise for short-term financial gains, the cost to human lives and organizations is devastating. The most vital protocol in any industry is recognizing that real competence will always speak louder than credentials. As the audience erupted in applause, I looked at Clara and smiled. The long journey that had begun with a cold ultimatum in a windowless human resources room had come full circle. Walking away at 12:45 p.m. was never about seeking petty revenge. It was about upholding professional standards, protecting industrial safety, and demonstrating that true technical mastery is priceless. When you know your worth and stand firmly on your principles, no corporate spreadsheet can ever undermine that foundation.